In a previous section, we discussed Avogadro's number and the mole, but I want to reiterate here that 1 mole is going to equal 6.022 times 10 to the 23rd of something. And using this conversion, we can now start looking at different terms and putting some definitions together. And one of those that's going to be the most important for us is something called molar mass. And molar mass can be described in the following way. The atomic weight of an element in atomic mass units is numerically equal to the mass in grams of 1 mole of that element. So what we can say is this. If I have 1 atom of chlorine, we know its atomic weight, or the mass of one of those atoms, is 35.5 AMU. What this definition tells us is if we have 1 mole of chlorine, it's going to be numerically equal to this mass in grams. So 1 mole of chlorine is going to be 35.5 grams. We can say the same thing for a gold atom. The atomic weight of gold is 197 atomic mass units. This tells us that 1 mole of gold is going to be equal to 197 grams. These same rules will apply to molecules. If you have a molecular weight of a particular molecule, you can then determine how many grams 1 mole of that molecule will weigh. So let's do an example problem. And the example problem we are going to do is it will ask us to determine the molar mass of glucose. And glucose is C6H12O6. So we need to determine this molar mass. So remember that when we look at a formula weight, the units are going to be in atomic mass units, and a molar mass is going to be units of grams per mole. These two quantities right here are equivalent numerically. So now let's look and let's determine what the formula weight, or how much 1 molecule of glucose will weigh. In 1 molecule of glucose, we have 6 carbon atoms, we have 12 hydrogen atoms, and we have 6 oxygen atoms. Now we can look at the periodic table to see how much 1 atom of carbon weighs. If we look, there's going to be 6 times 12.0 AMU. For the hydrogen, we have 12 of those times 1.0 AMU. If we now look at the oxygens, we have 6 oxygen atoms times 16.0 AMU. And the atomic mass units can all be calculated directly off of the periodic table. If we multiply 6 times 12, we get 72.0 AMU. 12 times 1 is 12.0 AMU. And 6 times 16 is 96.0 atomic mass units. Adding all of these together, we get 180.0 AMU. So this will be the formula weight for one molecule of glucose. We know from this statement that 1 mole, or 6.022 times 10 to the 23rd molecules, has a mass of 180.0 grams. And this 180.0 is going to be our molar mass. So that is the molar mass of glucose.